guys, I'm Trisha, and in today's video we're going to be implementing the local outlier factor algorithm on time series data. But before we begin, if you have a suggestion for the next Code With Me video, comment below with the hashtag Code With Me, and I'll try to make a video on it next time. So let's begin. I'm going to be using Google Colab as my development environment, but you can actually go in with any IDE you like. I've written the steps 1 through 6 so that it's actually easy for us to go about the process, and I have already imported the dataset file over here. I'm going to be explaining it in due course of time. Till then, hang on, and I'm going to first import the libraries NumPy as NP, Pandas as PD, and from sklearn.neighbors, sorry for the spelling, import local outlier factor. Now I have to read in this dataset, but actually I'll explain the dataset first. So I'm using this UCI Machine Learning Archive dataset, which is a Beijing multi-site air quality dataset. So these are the attributes which you'll see in the dataset. There is year, month, day. So it's clearly time series. And this is basically collection of various parameters which are measuring air quality at different points in the year, different months, at different hours in the day, and so on. Now the PM metric which you're seeing here, this on a very basic level is just the sum of solid and liquid particulate matter in the air. But for our purpose right now, we just have the units given and we can directly work with them. So I'm going to go back to my Google Colab and I'm going to quickly read in this data set. Data set is equals to PD underscore PD dot read underscore CSV, and I'm going to copy the path and paste it here, and we are going to print this data set. Also, before I run this cell, this data set, when you download it, this is actually a zip file. There are multiple cities. So this is what the data set looks like. I have just picked out one CSV file. That's the data set for Changping city. I'm sorry if I'm pronouncing it wrong, but there are a lot of files. You can work with any one you like. Coming back to my code, I'm going to run this cell, and there you go. You can see there are more than 35,000 rows and 18 columns in this data set. So there's a good chance that there are some null values as well. So I'm going to first pre-process this the following way. Data set is equal to dataset dot drop NA, that's drop null values, access equal to 0, which means that if there is a single null value in a row, that entire row will get dropped. So yeah, when I print this data set now, you can see that the number of rows have reduced from 35,000 plus, it's become 32,000 plus, which clearly means that there were null values in this particular data set. Okay, so in an ideal sense, you would actually like to go in with a feature selection algorithm, but for the sake of this video, I'm just going to hand pick some features because this is a super basic video, and I'm going to pick out month, day, PM 2.5, PM 10, and I'm going to also limit the number of rows to just about 1200 and print the data frame again. So there you go, you have 1200 rows and 4 columns. Now I'm actually going to prep the features we have at hand before we actually give it to the model. So I'm going to change the dimensionality of both these rows, PM 2.5 and PM 10. So I'm going to make it a NumPy array because it's actually easier a lot of times to access a NumPy array, and it just avoids unnecessary errors. So I'm going to take the feature PM 2.5 and I'm going to reshape it. So it's actually okay if you don't convert it into a NumPy array, you can work without that as well, but it's actually important to reshape this. And the shape has to be -1, 1. I have to do the same step for the next feature, except that I'm going to name this as Y and that feature is going to be PM10. And I'm going to also assign some simpler variable names to month and day. Instead of writing data frame of month, data frame of day, so month is equals to np.array df month, and this I'm going to copy paste this code and do the same thing for day. And I'm going to quickly run this cell to check for any errors. Okay, now I'm going to move on to create the model for the local outlier factor. So model is equal to local outlier factor. I'm going to invoke this method. Now this method takes actually a lot of parameters if you actually open the documentation, which I will link below along with the data set in the description box. But I'm going to deal with the two most basic hyperparameters, that is number of neighbors, which I'm going to fill in here, and the contamination. Okay, so the number of neighbors is basically the size of the neighborhood which we are considering for the algorithm, and I'm going to, let's say, consider this as 35. And contamination is basically the proportion of points which we are considering as isolated. So in very simple terms, this means that when there's an outlier, that point is obviously going to be an isolation. It's an outlier because the point is pretty much either isolated or it is not like any other point in the data set. So this parameter contamination is basically allowing us to set that threshold which we were setting at the end of the LOF algorithm to determine it as an outlier. So for the timing, let's just set this as 0.1. Run this cell, and I'm going to tell you guys a little more about both these hyperparameters. So the number of neighbors actually helps us get to the LOF score, which is assigned to every single point in this data set of 1200 into 4. And contamination is nothing but that threshold which is compared with the LOF score of every single point. Now, what should the number of neighbors and the contamination be? Either you need your domain knowledge for it, that you know your data so well and the application well, or there are algorithms and heuristic methods which are proposed by various research papers. I found a very nice paper which I will link in the description. You can go ahead and you can actually tune both these based on the heuristic which they have given. But I've just taken some random values for now. Okay, so now I'm going to actually go in with prediction. So the model is built. I'm going to write label is equals to model dot fit underscore predict, and I'm going to feed in these two features, and I'm going to print this labels array. So you can see that it's okay. Sorry, there is okay. This is label. So now in this array, wherever or rather whichever element is -1, it just means that the corresponding tuple is an outlier tuple based on this particular contamination and 35 nearest neighbors. So I'm going to quickly define a list called index. Now I'm trying to write a for loop so that we can see whether there are any points which are outliers. It's just a basic printing so that we can understand what actually happened inside this object. So for I in range length of label, if label, sorry for the spelling error, of I is not equal to 1. So if it's not equal to 1, that's when we say that it's an outlier. You'll have 1 and -1 values. Index dot append I. Now I am also going to print out another for loop for I in index print. We're actually going to index it back and use the month and the day array over here and see which month and which day had these values. So day, and I'm going to actually, I is basically storing that index value of label, and I'm going to use the day index, and yes, I'll just add a print statement here called outliers, and I'm going to run this cell. As you can see, there are like a host of days and hours where there are outliers. So a lot of these values are same. That's because we are indexing it by month and day. But if you would have picked it up on an hourly basis, if we would have extracted hour from here, then we would have gotten distinct results. So you can just take out one more feature right here, and then we can make an RNP array and print that as well. You can actually go ahead and plot a matplotlib graph as well if you're interested, and yeah, this was as simple as that. So that was the LOF algorithm. I have linked all the resources, the source code for this program, the data sets, the resources in the description box, so make sure to check that out. If you have a suggestion for me in anything learning or lifestyle, I'd love to make a video on that. So comment below and let me know. If you like this video, please like, share and subscribe to my channel. Until next time, bye.